So a little bit about myself. I'm a data architect and consultant for Fulton Analytics. I'm also a friend of Redgate. So if you need any cool tools or want to know about the cool tools at Redgate, let me know. It will help in your day-to-day work. They have some awesome tools for development and for administration. So if you haven't heard about them, go ahead and check them out. My Twitter handle, ReviewMyDB, my email address, and I also blog on occasion, so you can reach out to me there. As I said, Jacksonville SQL Server User Group, I actually run that group. I took over from Devin and Brian Knight a few years ago, and we run the SQL Saturday as well here in town. It's one of the largest, or if not the largest, data conference in Jacksonville. So we had it back in May. Jared has been there many times. He's sitting here shaking his head, yes. It is an incredible conference. We have MVPs that come out from all over the country and the world who come speak there. We normally have it in May. So if you're interested, our 15th anniversary will be next May. The user group that I run, we meet every third Wednesday, 6 to 8 p.m. at the Hampton Inn across from Cracker Barrel at the end of 202 and 95, except for May, November, and December. So if you like what I'm going to talk about here, we have this and other sessions similar to this every month, so feel free to come out. This is the link to SQL Saturday and SQL Saturday Jax. If you are interested in learning data or Power BI or anything related to analytics, come out to this one-day free conference. All right, now, today we're going to talk about what's new in SQL Server for the developer. I'm going to try to focus on those things that help your day-to-day tasks and writing functions a little easier in SQL Server. All right, so I want to try to figure out who I'm talking to, just kind of maybe cater more towards that. So what is your current role? How many developers do we have? Okay. How many managers do we have? Okay, 2 of you, all right. What about any analysts or QA? Analysts, QA, okay, awesome. Any other type of roles that I missed? Because that's just about everybody. Database engineer, okay, awesome. Anybody else? No, any DBAs? Well, sure, but this talk is, there's normally not a database engineer in this talk per se, so I normally don't ask about that. Any other type of roles I missed? All right, awesome. So mostly developers, that's good, because this is for you. All right, what version of SQL Server do you currently use? Who's in SQL 2000? Okay, good, good. What? You think? SQL 7? SQL 6.5? SQL 2005? 2008? What's that laugh about? You just got off of it?
I'm just informing people what SQL Server is we use.
Okay. 2008 R2. Okay, 2012. Does anybody know what SQL Server they're using? What are you using? 16? Okay. Anybody using 14? Okay. 16? Okay. 17? 19? Okay. Azure? Okay. So what are the rest of you using if you're not using any of those SQL Server versions?
I have no idea.
You have no idea? Okay. We don't know what we're using. It just comes out of this box. All right, so for those of you who answer, what editions? Who's using Standard? Okay. Who's using Enterprise? Who's at the beach? Okay. All right, so the edition matters in some of these things, right? But if you're on SQL Server 2016 SP1 and newer, some of the more enterprise features they've allowed now or opened them up to standard, which is nice. So you get a lot of the cool features like Query Store out of the box, which is nice. All right, so we're going to start with 2012 because that's when most of the, as I refer to, cool features came out for SQL Server that allow you to write code in like one function or one line compared to 12 or 20 lines, which is nice. All right, so if, everybody knows what this is in C#, I hope, right? So this is now available in SQL Server. So you can have this, see my code is running. Okay, so you could run this in SQL Server. So if first argument is greater than second argument, true or false. Okay, I'm going to try to run through these because we have a lot of content to go through. If you can stack them, right? So if you want to do a grade variation here and you want to grade Dilbert to see if him or his pointy boss passed or failed your class, here you go. Choose. It's similar concept to coding enums. So you could do choose, put your variable or your column, and then you could specify, in this case, you could go from 1 to 12, and it'll output your month. So my data set only was in May, but you get the picture. It'll push out the month by just a value and whatever your enumeration is. So here I have an example of what it would look like if you used choose for your month, or if you used choose for, say, a season. So we did a lot of work with, I've done a lot of work with e-commerce. So you have a winter, spring, summer, and autumn, and so you could specify that. You could also specify your enum to be like, say, a holiday season or your busy season versus not, if you wanted to specify that. So with choose, you can use choose, you could use if, or you could use a case statement. All three of those essentially will return the same results. There's no performance difference between all of them. So you can use whatever you'd like. Underneath the cover, SQL Server actually converts it to a choose statement, so it's not going to make a difference. The only thing is one is easier to read than the other. If you like that, then go ahead and use that. Try convert. How many of you use try convert to see if a value is actually the value it's supposed to be? Like, is it an integer? Okay? If you've done this before, a lot of times if the value isn't a value in that range, it'll actually throw an error. What it should do is give a cast failed or not, is what you would think, right? But a lot of times it doesn't work that way. So one cool thing now is SQL Server allows you to use the try convert, and you could specify if it is a particular value. So here you have a query where you have IDs, you have some characters, then you have some nulls. So normally you would want to say, hey, is my value a numeric function? Then you couldn't do that because it would actually throw an error. With the try convert, you can actually convert it and then use your try parse or try convert inside of there to actually make it not throw an error. So if you use the isNumeric try parse, you can actually convert your error without failure in this case. So in this case, it'll only pull 1, 2, 3, and then the values that you specified. So it won't actually error out if you have other characters in there, which is nice. Format. Format you can do a ton with. You can format pretty much any string, any date inside of SQL Server. Here's a bunch of different variations. It's also culture aware, so if you specify the culture, you can display the date based on the culture. It also has a lot of out-of-the-box patterns that you can use, as you can see here. And I'm just going to roll through these. You guys can look at them later. Era, I really don't know why they use this, but if you want to look at BC, you can. Or AD. I mean, I don't know who uses that date, but they added that in there. Historians? Yeah, I guess historians, yeah. But I don't think date goes back that far, so. All right, so you could format your time. You could format in 12 and 24-hour segments by just putting in your pattern and what you want to format it in. You can format in currency, again, and also use your culture.
This is 2022, right?
No, this starts in 12. So 12 and newer. So as I go forward, everything that from 12, it'll mark when we go to 14. 12 and forward, it's there. 14 and forward, it's there. So this is a fixed point to string. So you can take a fixed point and put it to string, and you could specify how many points you want to use. So 2, 1, 2, 3, 5, and then you can actually go negative if you want. You can also do a percent value. So if you don't want to add this in your code, you can just say format percent. Here we go. Same thing with the decimal. I don't know how many of you work in banking industries. How many use banking accounts with leading zeros? Anybody do that? Only one of you? Well, man, if this was around back in, like the early 2000s, this would have been awesome because you can actually do a leading padded zeros in front and return your data. So you don't have to have a calculation that'll actually, figure out how many zeros you're missing and add them. It's just one function. All right, format. If you need to format hex, you can, upper, lower, or X12. It'll also do degrees, so if you want to just format and put out your text as degrees, it'll do that. Format number, again, any format that you specify can be placed in that mask and then pushed out. You can also do a positive negative, so if you had an accounting app and you wanted to make it red or put brackets around it, etc., you could specify your positive versus negative, or if you had the rare case of no value, you could actually put an NA or a null there if you wanted to. Phone number, this is nice. So if you want to store your phone number, you can store it store it in integer or whatever format you want in a standardized format across the board. And then if you want to display it, you can display it however you want. So you don't have to store those extra characters in your database if you don't want.
Doesn't check for valid phone numbers, does it?
No, that you still have to do in your app. Try-catch. Try-catch now is more in line with how you would do a try-catch, I guess, in C#. So you can actually throw your messages and create your own severities. You don't have to actually create that in MSDB like you used to and use the specified messages that were inside of SQL Server. You can actually throw your error when and wherever you want inside of SQL Server, which is nice. Sequence. How many of you used to access databases where you had to create your own identifier, your own ID record? Only one, two, three? Okay, cool. So this is very old school, this is dating myself. You used to use access to where you would create IDs and then put them in your table. You wouldn't have the primary key auto increment your ID value every time you would insert a new record. So finally in 2012, they came out with a way to do this via function, more or less, but it also allows you to move data between, say, a QA or production environment and maintain your IDs. So I'll give you, for instance, we had a banking app that we had to import records from a large banking institution into our system. And we knew how many records they were importing, right? And we knew how many records we had in production. So we didn't want to affect our current production records. We wanted to import them without changing the IDs or creating any relationship issues down the road. So what we were able to do, again, this is before this came out, is we essentially bumped our IDs up. So we said, okay, our next identity column is going to be 6 million records up, right? And then we did all of our testing and imported QA and then just brought the records over when we were ready. Well, it would have been awesome to have something like this, sequence, where we could have just auto-incremented that inside of our primary key and used the sequence function to then say, hey, okay, our next sequence is not 1,000,001, it's 10,000,001. Now we have an empty block of IDs that we could use that's not going to be touched, and when we bring in that data, it allows us to utilize these IDs instead of wasting them, or say, bringing them in as a test, it didn't work, we delete them all and import them again, we still maintain our IDs. So there's a few use cases for this. I wish it would have been out years ago. We had to manually do this ourselves, but this is a cool thing. So you can either get the value manually from your sequence, your log sequence, or you can actually add it as part of your default when you create a table for your ID. Another reason why you would want to do this is maybe so you don't actually have to go back and get the next ID in SQL Server, which is actually overhead. So you could say, okay, hey, I know I'm going to import 100 million records, so cache 100 million IDs ready so that you can just increment them in memory, which is nice. So you can specify that here. You can also specify your increment. So if you wanted to jump, say, 10 records, you could. Or if you wanted to jump, odd or even numbers, you could do that. The other option you have is when you create the sequence, you can, like I said, you can put it in as your next value for, and then put in your sequence. So you can actually put that in as your primary key instead of identity column if you want. So you can have a little more control with that. And like I said, if you went from production in QA, you wanted to keep your values, you could essentially script out your sequence and drop and create it as need be in your other environments. So cycle, no cycle, that just means that I go 1 to 10 or I don't go 1 to 10 and keep going over. You can also specify your min and max, your cache. If you're loading a bunch of records, you can use your cache value and it'll cache that in memory instead of going back and getting a new value every time. All right, contained databases. Anybody here use a contained database? What do you do with your contained database? Azure. How many of you are using Azure? Okay, you're all using contained databases. The cool thing about contained databases is that your users that you create on there stay in that database. So when you move that from dev to QA to production, all your users are in there and you have no orphan users, which is nice. How many of you ever done a deployment where you had to go back and recreate your users because you went from a dev domain to a production domain and all your SIDs were messed up, right? So this helps eliminate that problem by having contained databases. And this is one of the reasons, or one of the things that Azure uses, and one of the reasons why it was actually created. All right. With always on, if you use always on, allows you to connect directly to the database because you have that account in that instance. Just make sure that when you're doing your initial development, if you use contained databases, make sure you think about that because you may have some impacts. It's easier for your DBAs because everything is contained. It's also easier for deployments because everything's contained. All right, there's some limitations. I'm not going to go through these here, but you can go ahead and read them. Unless you have replication or change data capture, contained databases will most likely work for everything that you have. Pagination. How many of you use page results in your applications? Okay, how many of you are using a CTE for your page results in your applications? How do you page? How do you page currently?
Skip and take.
Do what?
Skip and take.
Okay.
Offset in SQL.
So offset is one of the best things that I've seen come out of SQL Server in a long time for developers. What you had to do previously, you had to do a CTE. You do a with, and then you do your road number and your page, right? That's how it's been done for a long, long time. This actually is a very expensive operation. And a lot of times when I've come in and looked at developer code, when they're pushing it to production, I see that a lot of times they join to their table, and they also join back to the same table instead of just selecting from their CTE, which causes a lot of performance issues once you get to 2014. It's not as forgiving. So here's our example. We're pulling 10 records, page 1. Here's our 10 records. The new way he's already using is offset. If you're not doing offset, please do offset. Your DBAs will love you. All this does is it says offset, how many rows you're returning, and what page you're returning. You don't have to do a CTE, you don't have to worry about all that, and you hit your tables once. Still return your same 10 records. This is the old execution plan, what it looks like, okay? This is the new way with offset. It runs in about half the time, because what it doesn't do in this is it doesn't traverse the entire data set. If you run a CTE and do paging that way, it will actually traverse the entire data set before it returns the records. So if you do offset, your performance will increase quite a bit. All right, how many of you have heard of column store indexing? How many of you are using it? Nobody? All right, how many of you have a log table in your database? That just, you dump records in and dump records in, dump records in. Okay. If you have a log table, you probably should be using a column store index on it. Probably. How many of you do analytics or reporting? Okay. If you have tables in your analytics or data warehouse side of things, you should be using column store indexes. Okay, so how many of you don't know what a column store index is? Okay, So a few of you. All right, so everybody knows what a regular table is, right? Okay, table is stored inside of SQL Server. It's called a row store. So everything is stored in that row, okay? With a column store index, the data is actually stored vertically instead of horizontally. And then it's compressed. And that's where they get the compression. So let's say you have an address table and you have, 100 million people with the state Florida, okay? In a row store table, that 100 million records would have Florida or FL in it every single row. In a column store index, that value is only stored once, and then it has a meta pointer to the other records. So you can see if you're not storing 200 million characters, F and L, inside of your table, it's going to save you a lot of room. So there's two types of column store indexes. There are clustered and non-clustered. The clustered encapsulate the entire table. The non-clustered, you could pick and choose your columns. So if you have an OLTP table in your application, you can use a non-clustered index if you need to, say, aggregate some data on that table more frequently, but it's not necessarily a data warehouse or analytics table. So you can kind of get the best of both worlds. And in 2019, SQL Server will actually take an aggregated query and convert the entire query for you into batch mode, is what it's called, instead of row mode. So you could kind of get some of those benefits out of the box without even putting indexes on them in 2019. So in some of the older versions, like in 2012, you couldn't use some columns, you couldn't update them, etc. As this is going on in 2019, there's essentially no limitations to clustered or non-clustered column store indexing. So 2016 and newer, there's only a couple. So in this case, varchar max, you couldn't use it in column store index, and then some of the spatial data types. But now you can in 2019 and on. All right, so there's some features you can't use it with, is obviously page and row compression. Well, you can't use two forms of compression, obviously, right? So page and row is for your row store, column store is for your vertical storing. Replication, change tracking, change data capture, file stream, obviously you can't use that on there. It's really simple to create it. You just say data compression equals column store, okay? Or column store archive. And then for your non-clustered index, you specify your columns, and you just say create non-clustered column store index. So I'll give you an example of how much space this saves. In a, and also performance. So in a table of 30 million records, if I do a count on a non-cluster or a regular table, it takes about 2 seconds to execute to return a count. If I were to do a clustered column store query to do a count on that, it takes only 46 milliseconds. So you can see the vast performance there. So if we were to do another query, again, on a value that is not indexed, that would take a little over 2 seconds on a regular table. It would only take, well, I mean, it's not really not indexed because it's part of cluster column store, but on another filter value, 106 milliseconds to return an actual specific value in a count versus just a count all. So still tremendously fast. So here's a non-clustered index. So again, this is filtering on a table with a non-clustered index. Instead of it taking over 2 seconds, it now takes a half a second. Again, with a clustered column store, only 56 milliseconds. All right, so here's a normal table, 30 million records. It takes about, 2.7 gigs of data or space on your hard drive or your server. With a clustered column store index, it only takes 1,002 megabytes. So quite a bit less. And if you were to say have a log table that you wanted to archive, or say last year's log table that you want to archive off, you could actually change the cluster column store index to a archive compression, and it would convert it down to 280 megs. So if you have a lot of data, especially log data or repetitive data, like if you capture your requests and responses for any of your APIs and you store that in a database, compress that, right? You don't need that in its full form. So 63% space savings from a standard to a clustered, 89, almost 90% space savings if you go archive compression.
What year is SQL Server?
Say again?
What year is SQL Server?
So this starts in 12 and moves up. So 12 and newer has this option. Now, it was only available in Enterprise until 2016 SP1. Now it's available in Standard and in Enterprise. All right, this is one of my favorite ones. End of month. How many of you know about this? End of month. You can really throw a date at it, and it'll tell you the end of month. Doesn't matter the date, which is awesome. If you want to find out last month's end of date, next month's end of date, oh, just throw in the date -1 or +1, which is awesome. All right, now we're going to go to 2016. Split string is in SQL Server. And there's actually a new feature in 2022 that makes this even better. So any string, join, specify your splitting mechanism, and then it will, in this case, I'm actually joining it to a table with IDs, so you can pass in a string IDs, and it'll automatically split the string, which is nice. Here I'm splitting emails, and you can see what that looks like, which is pretty awesome. Date diff big, you want to throw a date and see how long it's been since the date or how old you are. Throw in your date and it'll tell you how many years, how many quarters, how many months, how many days, how many seconds you've been alive. If exists, if you're doing a script and doing some schema updates, you could put in an if exists into a lot of your schema modifications, so you don't have to do, put in your whole select from objects, see if it exists. It's just if exists, done. How many of you use JSON in your applications? Okay, how many of you use SQL Server and JSON? How many of you didn't know JSON existed in SQL Server? All right, cool. So not only can you put JSON in SQL Server, but you can also output anything from SQL Server as JSON directly to your app. So if your app needed a JSON string, all you need to do is select all of your data and say for JSON auto, and it pops out a JSON object. You had to do zero coding for that. If you wanted to say, I'm going to put out a query, but I need to change some of the field names, all you do is you say change account ID as account number and say for JSON path, and then output your JSON. So I've used this. This is a tremendous tool in pushing data out, especially for web, for mobile devices, because it makes what you're passing across the wire very light. So here's a query where we're actually going to do nested object. So you can actually select, and this is from the Stack Overflow database. I select users and I select posts, and I select, say, the top 10 users, just because I needed some data. So here you have the account, which is the user. In this case, there's an empty object here because that user has no posts. And then this user here has 6 posts. So you can see that and see their title there. So again, just queried for JSON auto, output your JSON. If you want to store a JSON object inside of the database, you have the option to modify that inline inside of SQL Server by just using JSON modify and then passing whatever element and object changed through. You can also add or append, or you can delete if you want. And here's some examples of what that code does. Again, here, same thing, and you can also nest the changes if you want to as well. Compress and decompress. If you store JSON objects in your database, they can get pretty bloated unless you minify them, right? So you have an option to do compress and decompress on your own outside the scope of, say, page, row, column store level compression, which is nice. So as a developer, if you need to use this, this is at your disposal. No extra permissions, no extra schema changes. You can just use it. All you do is use the compress and decompress command, okay? So here I have my compressed data, which is actually stored in a var binary, and then I have my uncompressed data, which is in a var max just for this demo. But as you can see here, the uncompressed size is 9,208 bytes, and the compressed size is 2,330 bytes. So about a third of what it actually was. And again, if your field is varchar binary, which is how SQL Server stores it, all you do is compress to put it in, decompress to put it out. So it stores it in a smaller footprint.
How does indexing work on that compressed data?
So if you're in a JSON object, you're probably not necessarily going to compress your JSON object, or index your JSON object, right? I mean, you can. Yeah. So in all likelihood, I don't know that you would index that per se. I mean, you could, but most likely you would probably have other values in that table that you would index and not necessarily that JSON object. You typically don't index blob type of data. It's not that easy to do. I mean, you can do it to some degree, but typically objects like this where you have your whole object or you have a dynamic object, it's going to be really tough to index that. In indexing, really, you would have an ID or some other record that you point to and then pull your values. All right, so how many of you have heard of an execution plan? Okay. How many of you use an execution plan to see if your query is running bad? Everybody should have their hands up. Let's go. Everybody, except for the managers. I'm hoping you're not writing SQL. All right, so you know in SQL Management Studio that if you click the button, you can see your estimated plan, or you can see your actual plan after your query is finished. How many of you have written a query and it's just sitting there and sitting there and sitting there and it doesn't return, right? And you're like, what the heck is going on? Okay, well, in 2016, you can now use something called Live Execution Plan. You can watch your query in real time as SQL Server is building it. It includes your number of rows, your time elapsed, any warnings, etc., which is awesome. And this is what it looks like. So if you haven't used this, this is a great feature to use. Just a button up here, Live Execution Plan. And then as your query is running, you can see if it's building out, if the query plan is finished building. If it hasn't finished building, you probably need to go back and redo your query. But this allows you to cancel your query if you want to, or call your DBA and say, hey, kill my query. But you can see what it's doing in real time, which is awesome. How many of you have heard of Always Encrypted? All right, cool. This is an awesome new feature. It encrypts your data between your app, if you're using the ADO.NET library, to SQL Server and back so that no one can grab your data. So it's end-to-end encryption. There's not a whole lot you have to do as far as the application goes. It's handled inside of the driver and inside of SQL Server. So when the data gets sent across the wire, it looks like just binary code. So you could still use this inside of TDE. It works in flight and at rest. So it's another layer of security that you can use. So it's kind of like dual encryption if you use TDE. So you create a master key on the server, create your column key, and then it will encrypt it. If you use 462, which I hope most of you are not still on, there's a bug, so don't use 462 with this. There's two kinds of encryption. There's randomized, right? So every time you encrypt a value, it'll be different. And then there's deterministic. So if you need to index, you could still index if you use deterministic encryption on a column for always encrypted. If you use randomized, you're not going to be able to. So if you do a social security or email where you encrypt that in your database, you can still create your where clause and it'll still find it. Here's a script of how you create that. Here's how you do it in interface. It's really easy to do. Here's your key. You use your master key for your column, and there you go. And then on the column itself, you add this encrypted text with your algorithm and with your type. Here's deterministic, here's randomized, and then you create or alter your table.
So I imagine master key rotation is not something you normally would do. Like you just want to make sure that that never gets out.
Right. You don't want to have that get out, and your DBA will probably have to do that. So work with your DBAs. They will help you get this implemented. Yeah, and the key rotation in this scenario is probably going to be something your DBA will do.
Oh, so there is, you can key rotate.
You can, yeah. The only thing you have to do on your app side or in your SQL Manager Studio or whatever is you have to add this column encryption setting equals enabled. And then when you query your data, you can see that. If you don't have it enabled, if you run profiler, it looks like a binary string like this. When you query the database, this is what it looks like. But if you have an application that has the certificate, or has a driver and the connection certificate, then it will pass through. So SQL Management Studio column encryption setting is enabled, then you can actually see the data. Otherwise, it'll look like just binary. Stretch database. This is not a common feature. Anybody using Stretch database? So let's say you have a database and you don't have a lot of space on-prem and you want to push your cold data to the cloud. Stretch database allows you to take your cold data, say, not this year, but last year's data in the previous 5 years, and put it into the cloud. You can still query it as one table, doesn't change that. If you go prior to what you have on your hot storage, it takes a little longer, but not substantial. If you're doing analytics, in-memory OLTP now has in-memory column store indexing. So remember the performance that we saw with the 56 milliseconds of your querying your table? You now have that inside of your in-memory tables. So you can now apply that there. You can now use Polybase and R inside of SQL Server and actually run scripts and connect to other data sources using Polybase. Another feature is dynamic data masking. How many of you need to mask the phone numbers and email addresses and personal information when displaying to users? Should be everybody's hand. Come on, everybody's hand. This is an easy way to do it based on user roles. So you essentially can say, hey, my masking function looks like this, or in this case, we have a built-in one for email. When you insert your data, it's based on the user role. So in this case, if you're a reader, you can't see the data that's output, right? So when as a reader role, in this case, my credit card number looks like this, my email address looks like this, and my phone number like this. So this is masked data. Now this is not encrypted. If you store your data like this, the data is still there. You can still get to it if you have right user rights. It's not encrypted. Completely different. Now you can still run the data masking on non-encrypted data, but you can't run this in conjunction with your encrypted data. Okay? So if you have a read-only user or your profile user account group or whatever has the rights to see the masking, then this is what it looks like when it would be returned. Row level security. Anybody using row level security? All right, awesome. A couple of you. So row level security allows you to specify groups or users or filters or even certain periods of time where a user can see rows in a database. You can configure this to be as complicated or as simple as you want. So if you have sales managers, they can see all of the sales data. If you have a salesman, they only see their data. And you can just manage this with groups or functions inside of SQL Server. Allows you to control your data and secure data more. Key thing about this is handling creation of the record. So it doesn't take a lot of overhead when you're actually querying your data, which is nice. So you can work on a simple ID, username. It's as complex or as simple as you want it. All right, Query Data Store. How many of you have heard of Query Data Store and or used it? All right, cool. 2 of you? Good. So this is an awesome feature. Let's say that you're deploying your code and you're running it in QA or in your performance environment and you want to see how your new version of software has run or is running against the old version. As long as Query Store is running, it will capture all of your execution plans, your runtime statistics, and then you can go and look inside of this and see, okay, this week versus last week, how did it perform? Where are my regressions? What is the executing 100 million times that you should have only executed 20,000, right? You have the plan to force bad plans. Like let's say you have a plan, you have some parameter sniffing, you want to force a different plan because it's going to execute better. You can do that using query store. And you can also look at a full history of execution. Obviously, dependent on your settings, you can make your query data store as large or small as you want. And you can see which queries are hurting you with a new deployment, and you can fix those quickly. So this is what the interface looks like. And inside of SQL Server, it's just right there beside your store procedures and tables. It's called Query Data Store. You could select your duration, CPU time, logical reads, writes, physical reads, memory consumption, and execution count. You can see all the different execution plans for your query. You can click on each different query to see which one is running more costly than the next. You can configure the options here to say, hey, I want to look at like the last hour versus yesterday, or say this week versus last week.
So you're saying you could tell it that the next time it encounters a specific query, it will execute under a plan that you have told it to execute under? For
Yes.
X amount of time?
Yes, so I'll give you this for instance here. You notice how there is 1, 2, 3, 4 execution plans here. You can see how this gray one here seems to be running pretty long. This is a millisecond duration here, and this is a time duration over period. So all of these queries were executed. It selected this plan here, okay? And then you have this one here, is a little better. Then you have this purple one here, and then you have this light blue one. Well, in this case, the two variations of the light blue seem to be the fastest execution plan. So I can come in here and I can say, hey, this is the plan I like. This is using a seek versus, say, a scan in my query. And it's using the right index that I created. There might be some parameter sniffing going on. So, hey, let's make sure that anytime this query or this store procedure with this query is being run, I use this good plan here. So you can say, click here, force the plan, and anytime that query, whether it be I mean, all of these are the same query, okay? It's just a different plan. It will run on this plan and execute that plan every time. So it'll use that index that you created, it'll seek that index you created, and return the results fast compared to the other ones. So if this execution plan here is using a scan and taking longer because it's traversing the entire table, you don't want to use that. So it'll use the seek one. So this is an awesome feature. Work in conjunction with your DBAs to do this. They'll be glad to make sure that this is fixed. Now, in 2022, there's a new option to where it will actually, with parameters and parameter sniffing, it actually will detect those variations for you and allow you to actually store multiple good query plans based on your IDs in 2022. So even further, helping you monitor any variations in your execution plans. All right, how many of you use a log table to track changes in a table and store values in a long table? Only one of you? Two of you? Okay, a few more of you. So how many of you have not heard of temporal tables? So temporal tables takes all that logging work away from you, which is one click of a button, okay? You don't have to write a trigger. How many of you have written a trigger to store that data, right? Everybody? You don't have to write a trigger. It stores the data in its own separate table, and you can go back at any point in time and recreate your table. You don't have to get it back up. If you updated the entire table with a where clause and changed all of your data, guess what? It's in your temporal table. It's in your historic table. So this is one of the coolest features. It saves a lot of time. So you could query data and look at any point in time or what it was yesterday or what it was 2 days ago or what it is now. So it's really two tables, and the complexity is really hid from the end user. You don't have to worry about it once it's turned on. So SQL Server maintains it with a start and end time, and that's essentially how it's managed, and it monitors the entire record. It's really good for compliance and performing auditing. So if you need to know who changed their password and when, you can always figure that out. So all you do is create a normal table, like you would, and then you say system versioning on, history table, and then specify your history table. I like to use history schema. That way all my history tables are together, but you can do whatever you'd like there. The only thing you have to do is you have to add these 3 lines, your start time, sys end time, and the period for system time, and then put those 2 columns here. So it's really simple. And then when you query, you could say, query my table as of what date? You can see that at this point in time, I had 1 record, and then I had 3 records at a different point in time. And then at this point in time, I had a few more records. And if you go in and look at the records and say, hey, I want to see it based on this time and then this time, you can see that the username changed. So this is a really invaluable tool. You don't have to worry about triggers. It manages all that for you, which allows the performance of your application to stay with the application.
I was just reading your code, but you went a little bit fast. You can alter a table and add it, right?
Absolutely, you can.
So if you wanted to like migrate from the old style to the new style, maybe turn it on and then stop doing it the old way?
Yeah, so I would turn off your DDL trigger.
Yeah.
I would add the columns, and then I would alter the table to add the system versioning to it, and with the table name, and you're done. Now, obviously, it's not going to say fix everything in the past.
Historic stuff.
It's not going to do historic stuff. But if you wanted to, you actually could take your big table, your large table, and convert it based on your timestamp and insert it into the history table if you wanted to.
Oh, wow. Yeah, that's a good idea.
Yeah, I've done that, and it works very well.
So with that would probably extremely reduce the amount of data.
Absolutely.
Size.
And then if you wanted to, you could page level compression that history table and make it even smaller. Which, I mean, across the board, if you use,
Super useful.
yeah, and across the board, use page level compression as much as you can. I mean, there's no reason why you shouldn't. It doesn't create any extra overhead for SQL Server. Page level compression, definitely use it, especially if you're on enterprise. If you're on enterprise and not using page level compression, you're shooting yourself in the foot. Your backups are going to take longer, all that. Like, compress. All right, so here's a few more queries. I got examples in there. I'm not going to go through all those because we only have a little bit of time, and I got a lot more to cover. In-memory L2P, every version, they've increased how much memory you can use. They increased the indexes and the collation. They can use parallel plans, TDE now for in-memory. So even if it's in memory, it's encrypted, right? No one can steal it out of memory and read your memory after the machine is shut down or when they turn it back on and try to get it. It's improved performance, garbage collection, so it actually has multiple threads too when loading the data. In this version of SQL Server, we're on 16, you can't support all these data types, but down the road you can. They finally allowed you to do normal queries, right? Joins, distincts, and ors, nots, which you couldn't do in in-memory previous versions. So all of those are now available. All right, 2017. We've got 11 minutes left. See if we could do this. See if we could get the 2022 stuff. I wasn't sure if I could, but I've cut a little bit out. So you can actually run SQL Server on Unix flavors. So we can use all of these, and you can run it in Docker. You can actually run it in your Mac OS if you want to, which is pretty sweet. You can now run SQL Server on a Raspberry Pi in case you wanted to. SQL Server Edge, which is pretty awesome. This is one of my new favorite ones. It's concat WS. So it concats an address whether you have values or not. I mean, I remember writing strings. Hey, do I have this? Okay, get rid of this comma. Do I not have this? Add this comma. All I have to do is say concat, put my comma in my space, put all my fields, and voila. Look at that. I don't have to do any null checks or empty string checks. It's right there. So you can do this with any data you want to bring together, which is nice. So for address labels, that's really cool. All right, trim, and there's a new feature, I think in trim in 22, but it wasn't working for me, so I didn't demo it. But trim now, instead of L trim and R trim, everybody knows what those are, right? Left trim, right trim. You can now just do trim. It'll trim both sides for you all together. It'll also trim a specified character or set of characters. So in this case, it has a pound at the beginning and a period at the end. It says trim set of characters from the string, which is nice. You can actually pull specific characters out. So here's some examples of what that does.
Those look like they're in the same order, like the pound before the dot in both instances. Does it have to work like that?
Yes, it has to work because it's trimming, it's coming, I believe it's coming from this way. I tried to do it the other day, and I mean, now it could be a bug, right? But I don't know because I had to find out. But I tried to trim it where I would just pull, all the characters out, right? And it didn't seem to work. So it's not necessarily like a full replace, but it's from the ends, right, in this case. All right, translate. This is kind of like a replace. Instead of using multiple replaces, you can use translate and then specify what you're translating from and to. So in this case, this is the original string here. This is the replace function from the original string, and then here's a translate function from the original string. So you can get to it the same way with translate, and you can use your brackets to your parentheses here. GeoJSON points to WKT format and vice versa. WKT is well-known format, so in this case, it's just your point and coordinates. Within group, so you could do a string aggregate. This is a cool function. If you want to say send emails to everybody in Jacksonville, you just group your query by your city, and then it appends your string all together. So this is really cool. So again, you're just selecting your city, which is your group by, your email address, and your split, right? And then it puts that out as text. So that's kind of cool if you want to do that. All right, 2019. 2019 now supports Red Hat Linux. You can install SQL Server on Red Hat. So all of you who have shops that say, hey, we're only going to go Linux or Unix, well, now you can do SQL Server if you want. All right, new features, graph features. You can actually do a graph database inside of SQL Server now. Anybody know what graph database is? Anybody use graph database? I just recently started playing with it. So if everybody knows what a Twitter and Facebook feed is, right? So think of that as a graph object, right? So the tweet or the post itself is your node, and all of the things like how many people like it, how many people commented on it, those are your edges. That's the simplest way. So everything you use today is really a graph database. And you can actually store graph as an object, right, inside of SQL Server, or you can store it as a document DB. So in SQL Server 2019, you can use derived table or view aliases in graph matching queries. There's match support in merge DML and edge constraints, which can now be supported to do cascading delete on the edge constraint. So if you need to delete an object, it'll remove all of your edges. So how many of you know the difference between a varchar and an nvarchar? Okay, anybody want to tell me? About half the group that knows.
It is not locale specific or something like that?
No. So nvarchar is Unicode. Varchar is not. So if you're using, say, a Unicode character set type, like Chinese, Japanese, Hungarian notation, you could store your data or need to store your data in nvarchar, okay? For those of you who don't know how many, well actually, how many of you know how many bytes one character takes in an nvarchar versus varchar?
4 to 1. It's 4 bytes per character.
Someone said 4, anybody else?
For nvarchar would be 8.
So it's actually 2 to 1. So if you have a character A and you store that in nvarchar, it's going to take 2 bytes. If you have it in varchar, it's going to take 1. So if you have your database, this is an extra tidbit, this is not in there, this is from my performance session, but if you use nvarchar, unless you're storing a Unicode character in it, don't. Use varchar. You are taking up twice as much space with every single column, with every single character, than you would otherwise. And that means all your data transfers are twice as long as they should be, all of your backups are twice as long, all your restores are twice as long, all your indexes are twice as large and taking up space. So if you want to make your DBAs happy, change your nvarchars to varchars, it'll impress them. Let's say you need to still use your Unicode character. You can actually now, using UTF-8, store your Unicode inside a varchar field. So you can store that extra large data in there, and it will not take as much. Combined, it may take a couple more bytes to store it in that same field, but it's not going to take it times 2. Okay? Another new thing in 2019, you have machine learning, Java extension with resource governor, for those of you who like to write Java that hog the whole system. New Polybase external connectors, so you can literally reach out from within SQL Server using Polybase and go query Azure Data Lake or Oracle or Teradata or MongoDB. And it doesn't actually transfer it, you can actually query it over there. It gives you a picture of what the data looks like, and then if you want to, then you can bring it over. So it's very lightweight, very performant. How many of you have ever inserted data into SQL Server and gotten this message, string or binary would be truncated? Well, guess what? In 2019, it tells you which column and which table. Finally. This one has been asked for so much. I'm so glad they finally put it in there. All right, SQL Server on Linux in 2019 now supports MSDTC. Everybody know what that is? Anybody don't know what that is? Okay, MSDTC is Microsoft Distributed Transaction Coordinator. If you have multiple servers or multiple connections inside of your application, MSDTC will essentially say, hey, go make a change here on this server, this server, this server, or this database, and this database. And when it's all done, commit. If it doesn't, it has the ability to roll it all back, which is what MSDTC does. Machine learning is now Linux. Open LDAP support Microsoft Container Registry. So if you want to make sure you have the latest and greatest SQL Server edition or version, it's in their own registry. ComStore indexes, you could actually test to see how much space you'd save by using this estimate savings. If you clone a database to say deploy to another environment, it keeps your statistics now. You don't have to update those. This will tell you the size here of what it would be if you could changed it. When you troubleshoot pages, it now gives you the specific page and where it is if you have corruption in your, if you want to do database weights or corruption, if you want to check a page. You have a approximate count distinct. Let's say you have 2 billion records. It's going to take a long time to do a count or group by. You can do an approximate. It'll assess the data, or it'll assess the data, aggregate those values in a fraction of the time, and be within 2% of the actual response. So if you need to do some prelim numbers without actually doing the number crunching to see what it looks like, approximate count distinct is good. All right. I'm out of time. Anybody have questions? Or I can try to run through if you want to stay for another like 2 minutes.
You can go a little over. We have 2 hours for lunch.
Okay, I was going to say it's lunchtime, so hopefully nobody's too hungry. There's my contact information if you want to hit that real quick. You can find me. All right, so 2022, it just came out, CTP 2.0. They'll do several of these before they actually release it, general availability to the public. They don't have a date yet. 2019, they went to, I think, 3.2 or 3.4 before they came out. So, string split. Here's the new function I was telling you about, the new part of this function. You can actually create an ordinal reference flag. Now, this is not your ordinal reference. This just says use ordinal reference, or you can use ordinal reference. So, there's always going to be 1 here, or true. But here in your where clause, This is where you put in your ordinal. So in this case, I'm cross-applying the string split of authors. Ordinal, I want the first one, or I want the second one. In this case here, so I pull the first author and the second author out of this string. So you can do a string split, but you can specify which one you want. So that's kind of cool. If you had a string that wasn't all authors and it had various informations like pages or issue or whatever, you could pull that out and specify it in different fields by using the ordinal reference. So that's kind of a nice feature. Generate series. You could say it's a loop, generate a series 1 to whatever number, start and stop. You could join that or do whatever you want with that. You also have a step. If you wanted to skip every 5 numbers, you could do that as well. Start and stop, skip every 5 numbers. It works with decimals as well. So if you wanted to step on decimals, you could do. Logical function, greatest and least. If you have multiple values in a query, like say dates or values, you can say, hey, I want the greatest value between these two, either an actual value or actual tick columns. Here I did a sample of a published and a journal date. So it'll pick the greatest one in the where clause or the least, and it'll return those values. You have now the option to do, is this actually JSON inside a SQL Server? So you could do this, you could check it on an array or an object or a scalar number, a string, or a value to see if it's actually truly JSON. JSON path exists. Let's say that you're querying through your objects, you need to make sure everybody has a Twitter handle. Anybody who doesn't, you want to add it. You could do something like this, or if you wanted to see if they had an address, you could do that. And in this case here, this obviously doesn't exist, and so it wouldn't return that value. JSON array, this is really cool. They still have some problems with this in CTP or in Azure, so it's not working. I found a couple bugs, but this is really cool. Instead of just converting your entire query to JSON, you can actually have a column as JSON, as an object or as an array, which is awesome because a lot of times I need something else besides my JSON object to be passed back to the application, which is nice, right? So this is awesome. So I could have a column be returned, and then I could specify my JSON array from other fields if I want to, which is awesome. JSON object, same concept, but again, it's an object versus an array, right? So you pick and choose what you want. Window. So if you ever do windowing functions, this is the old way, partition by. You have to run that partition by every single one. The new window way is you just kind of do it once, and then you do over win, and you can specify that down here. There are some other more complicated options with this, but I haven't explored as much, but this is essentially the basic difference between the two. Instead of doing it multiple times, you just do it once. Helps clean your code up. All right, any questions? I have links to resources for 2022, and then back at the end of 2019, I have links for all those resources.
Thank you.